All right, we're streaming. Audio levels look good. So today is going to be, yesterday we got the Elixir server set up and we got a ping going back and forth, ping pong, so we can measure the round trip time. Yeah, that was all done yesterday. The thing I want to start on next is just login, so I can have a concept of a user and then start building out their what is it called? Can't think of words right now. I want to start building out their, can't remember the word. I have it in here. Their vault. So I'll have a user vault, which will have links to all of their vaults for specific groups, which will have their what is it called? Can't think of any words right now. Their keys, their public keys. They have a different name though. Sender keys. So yeah, I want to start building all that stuff out, the vaults. Because once I have the vaults, I can start making the group vaults. Once I have the group vaults, I can actually start trying to create groups and send messages across the groups. That's kind of the path. To do that, we're going to implement login. I talked about this a little bit yesterday, which is I could require some strict login, but I just don't want to do that. Most people aren't used to having to have some super long password or something, and if they forget it, they get locked out. So what I'm going to do is I'm going to try to separate off login from restoring history. And to restore history, maybe I'll require passkeys or a long phrase. Passkeys are not perfect, but they're good enough for most people. But that way the history can be more protected. And then there might not be any recovery if you lose the passkey or if you lose the phrase for the history. Maybe at some point I could make it so that someone could restore a backup to someone else. The reason I'd be hesitant to do that is because the person should only be able to get the messages from when they joined. And that's a little bit hard to do because if someone else shares their history with you, that history would potentially include messages from before you had joined. So you'd have to account for that somehow, and it just seems like a pain. So I'm not going to worry about that right now. The thing I'm going to worry about is trying to separate off login. So login, then potentially you can do like email verification for login. So if someone got access to your email, they could see what groups you're in and pretend to be you, but they couldn't see any of the history at least. So I think that's a pretty good distinction. And yeah, I think to do this, we're going to try to use MLS, messaging layer security. It's a sort of a tree structure for how you manage keys. One of the problems with Signal is that when you remove a member, you have to rotate keys for everyone, so that everyone has sender keys that are sort of these public keys. And when you remove someone, you need to make sure they can't decrypt all of the messages going forward. And so you rotate everyone's keys at that moment when they leave. And so that's an n squared operation. I was reading a little bit yesterday, and it's more than n squared because each device you have is also basically like a separate sender key. And so it means you have to rotate those as well. So it's actually like nm squared, where n is the number of users and m is the number of devices they have on average. So that's kind of a problem. MLS lets you do this, I think, in log n time to do a member removal. To rotate all the keys, I think it's n log n, but you don't need to rotate all the keys when someone leaves. So that's kind of the benefit. Because if Jeff, Alice, and Bob are talking to each other and Carol leaves, they can use a different key from the get-go, so that when Carol leaves, they don't have to rotate each other's keys. That's kind of the idea behind the tree structure, right? It's avoiding rotations. It's setting up the keys in such a way that you can avoid rotations between other members who are unrelated to Bob or Carol. Whatever. There's just no reason that Alice and Jenny should be talking with a key that Bob can read. right? So I think that's kind of the main idea. But I'm going to read more about this. I might be wrong. I was wrong about a couple of things yesterday. That, like, for example, I thought WhatsApp, I thought they were sending your whole history. If you change device from another, the person you were talking to could send the whole history of the message, the chat, but it's actually not the case. They're only sending unsent messages can get sent without your confirmation if the user gets a new device. So on Signal, if the user gets a new device, those messages will fail to send because they'll have a new sender key. But on WhatsApp, they'll just re-forward those messages to the new sender key, which is a risk because it means that the client is trusting the server to give them a true sender key. You could basically just, the WhatsApp server, if it wanted to, it could just have you send messages arbitrarily to anyone. So, yeah, so I'm going to start by reading about these things. Messaging layer security. Like I said, I have some sense of an idea of how it works and kind of what some of the trade-offs are, but I'd like to really have a better understanding so that if the chat model tells me something, like, you know, a lot of this stuff is pretty good, but there's just certain things where I'm like, this could just be wrong. Like, you can't trust what it's saying necessarily, so you have to double check. Because it might just come to some conclusion, and if you just knew, you'd be like, no, that conclusion is wrong. Like, what you're assuming here is not actually true. For better or worse, like, it could be assuming something about the security model, it could be assuming something that's possible that's actually not possible. So, yeah, we'll read about this first. Take a look at our plan for our structure for the app. See if we need to do any modifications for that. This is all going to take quite a bit of time. And then if we're good to go, I want to start implementing passkeys and login, because that's the first step. So let's see how it goes. I think I had these open in order of kind of like detail. Let's take a look at this. Messaging layer security, secure and usable end-to-end encryption. The IETF has approved publication of messaging layer security, a new standard for end-to-end security. A new standard for end-to-end security that will make it easy for apps to provide the highest level of security to their users. End-to-end encryption is an increasingly important security feature in internet applications, keeps user information safe, even if the cloud service they're using has been breached. Yeah, this is the thing people don't understand. It's like not just governments. I mean, you should be skeptical when the government wants information. There are times where it's worthwhile for the government to be able to have information, but these things always get abused is kind of the problem. You know, like, Amazon just gives access to your Ring cameras to the police. And sure, initially, it's probably always good cases. But then once they know they have that power, they just start using it all the time, breaking people's rights. And then also, like, what happens when there's someone at the police who is stalking someone? You know, these are just people. So anyways, you should be skeptical of the government having carte blanche access to stuff without any oversight. But even without that, there's a risk that, you know, these companies get hacked, or a state actor from another country or something comes in and basically just gets access to all of the data. This is all your photos and stuff. And I think people might realize more how much this matters with the AI stuff, because putting your photos out there means people can impersonate you, your voice and your photos. So I think people are going to become more sensitive to privacy going forward, especially young people. Old people are too dumb to pick up on changes in the world. Just ignore the consequences. I've been living for 40, 50 years. Everything's been fine. I don't see any problem. For an app to provide end-to-end encryption, it needs an extra layer of cryptography that sets up encryption keys among the devices participating in a conversation, so that these devices can encrypt users' data in a way that the cloud services can't decrypt. Before MLS, there was no open interoperable specification for this layer. MLS fills this gap, providing a system that is completely specified, formally verified, and easy for developers to use. MLS builds on the best lessons of the current generation of security protocols, like the widely used double ratchet protocol. Double ratchet is basically, I was reading about this yesterday, where each member, when they're talking, like if there's two people and they're talking to each other, they don't actually, when they need to, they need to regularly change the keys. And so they do it through this ratchet where they use the previous key, they get a new key, they don't have to exchange any information, and they both can ratchet forward. So yeah. MLS allows for asynchronous operation and provides advanced security features such as post-compromise security. Unlike TLS 1.3, MLS provides robust authentication, and its security properties have been verified by formal analyses. MLS combines the best of features of these predecessors and adds on features like efficient scaling to conversations involving thousands of devices without sacrificing security. Draft versions of MLS have been deployed at scale to protect sensitive, real-time conversations in WebEx and Ring Central communication protocols. These early developments provide validation of MLS's ability to work well in real-world scenarios. At the scale of major communication services, other apps such as Wire, Wicker, and Matrix are planning to transition to MLS, and the IETF MIMI working group expects to use MLS as the end-to-end encryption layer in their solution for interoperable messaging. This is just the beginning of it for MLS, though. There are already a handful of MLS implementations, including multiple open source implementations, but more implementations will make it easier to use MLS in more places. Likewise, more deployments will provide valuable lessons on how future versions of MLS need to improve. And while MLS is a major piece of the end-to-end security story, there are still important pieces yet to be written. For example, creating a store identity that can integrate with MLS's authentication system and secret management that helps users have a more seamless experience. Strong identity. Strong. For example, creating a strong identity that can integrate with MLS's authentication systems and secrets management. Yeah, so it's basically saying you still have to set this up yourself. That part. The part where you go from someone logs in to someone is a part of the group in a pseudonym way. So that didn't really tell us much. What did we learn? What did we learn from this article? That it exists, and that's about it. There's a few open source implementations. Yeah, not much details in this. What is messaging layer security? MLS is a new global standard developed by the IETF, the same community that defines the Internet core protocols. Its goal is simple: make E2E end-to-end encryption efficient enough to work at any scale. Traditionally, every participant in a conversation needs an individually encrypted session with each chat member. This creates a complex web of connections growing exponentially. This is how other messengers like Signal or even WhatsApp handle E2EE conversations. It's also why their group sizes are limited to the low hundreds. Instead of creating separate cryptographic sessions for every participant, MLS manages keys dynamically within a group. For example, if John sends a message in a 400-person group, his device needs to encrypt this message at least 399 times, assuming each recipient is only using one device. Realistically, each participant is most likely using two devices, desktop and mobile, or maybe a third, like a tablet, thus requiring the need to encrypt the message 399 times 2 times in addition to any other devices John is logged into to also view this message. This is slow, and over time his device might even run out of memory. With MLS-enabled chats, the message only needs to be encrypted once, and then is sent securely to the whole group. Yeah, I mean, Signal already does sender keys, so this isn't true for Signal anymore. When was this published? 2025? I'm apparently was scrolled down on this before I didn't start at the top of this article. Demystifying MLS. Secure communications become critical, blah, blah, blah. History of end-to-end encryption. It ensures that messages, traditional encryption protocols like double ratchet, made popular by apps like Signal, were never built for the scale of modern enterprise communication. Double ratchet was built to be a simple and practical mechanism for handling one-to-one conversation. It works well for small groups, but when hundreds or thousands of participants are involved, each using multiple devices, encryption becomes inefficient and slow. Security came at the cost of performance and scale. This has a direct impact on business operations. Large teams cannot collaborate effectively if encrypted channels slow down, fail to sync, not support the number of people required for critical conversations. Okay, now we're back to where we were. So in very legacy systems where you don't use like sender keys, you would have to encrypt the message to every other member every time you send a message. With MLS enabled chats, the message only needs to be encrypted once and then is sent securely to whole groups. I mean, this is how Signal works too. It's just the issue with Signal is when you need to rotate the keys, you have n squared rotations, which is not ideal. And that you have to incur that cost when someone leaves the group. So, and it's difficult to amortize it. You can amortize it a little bit by only rotating when the person needs to send the next message. So like every time one of the group members sends a message, you can do the rotation. You can amortize it a little bit, but yeah, not as much as you'd like to be able to. The result is the foundation for truly scalable, secure collaboration. MLS makes it possible to host large, fully encrypted group chats and conference calls with the same security guarantees once reserved for private one-to-one conversations. I can't play this because I'll get copyright strike or whatever. Let's just see. I don't know why YouTube has so many issues when I load a video on other websites. This isn't working. Wired's role in building the standard. Wired has been part of the MLS journey from the start. Since 2016, our engineers have contributed to the IETF working team. What is Wired? I don't even know what this is. Enterprise grade messaging. Invisible, always on. European thing. It's like a European signal you can use for your company, I guess. Seems like. Okay, so they've been involved. This gives organization confidence that MLS on Wire is working correctly, stable, and ready to go. Wire is not the only message to bring MLS into full production, but also the most experienced. Okay, talking themselves up. MLS represents a turning point. Organizations approach digital security. Just as HTTPS transformed the web, MLS is redefining how teams connect and collaborate at scale. Wire continue. Okay. The video is probably the most useful thing. It doesn't tell us very much either. Failed to play. Now we'll read the Wikipedia article, which will actually probably tell us something useful. Oh, it's pretty short. Maybe it won't tell us anything useful. Let's see. MLS is a security layer for end-to-end encryption. End-to-end encrypting messages is maintained by the MLS working group of the IETF, Internet Engineering Task Force, and is designed to provide an efficient and practical security mechanism for groups as large as 50,000 for those who access chat systems from multiple devices. Security properties of MLS include message confidentiality, message integrity, and authentication. Membership authentication, asynchronicity, forward secrecy, post-compromise security, and scalability. The idea was born in 2016 and was first discussed in an unofficial meeting, IETF 96 in Berlin, with attendees from Wire, Mozilla, and Cisco. Jeez, 2016. I thought this was 1986. Initial ideas were based on pairwise encryption for secure one-to-one group communication. 2017, an academic paper on asynchronous ratcheting trees was published in Oxford and Facebook, setting the focus for more efficient encryption schemes. The first BOF, Birds of a Feather, Andrews organization, took place in February 2018. As of 2023, the IETF has approved publication of MLS as a new standard. It was officially published in 2023, July. At the time, Google announced it intended to add MLS and to end-to-end encryption used by Google Messages over RCS. In March 2025, the GSMA announced that the Universal Profile 3 standard of RCS would support MLS. Okay, so basically RCS is going to use MLS. Matrix is one of the protocols declaring migration to MLS. Research on adding post-quantum cryptography to MLS is ongoing. The IETF has prepared an internet draft using PQC, algorithms, and MLS. Post-quantum cryptography. Okay. Basically, this seems like where people are going right now. And I didn't learn very much at all. Well, here we go. Can you explain the basic structure? How MLS messaging security works? Thinking. Messaging layer security is a protocol designed for secure group messaging. Core concept, the ratchet tree. MLS uses a binary tree where each leaf represents a group member. Each node in the tree holds a key pair. The root of the tree produces the shared group secret. This tree structure is what makes MLS efficient for large groups. Updates scale logarithmically rather than linearly with group size. Key components, key packages. Before joining a group, each user publishes a key package containing their identity key, a one-time use init key, and supported capabilities. Each user publishes a key package before joining a group. Each user publishes a key package containing their identity key, a one-time use init key, and supported capabilities. These are stored on a delivery service so others can add them to the groups asynchronously. Group state. Every member maintains a consistent view of the group state, which includes the ratchet tree, the current epoch number, group membership, and derived encryption keys. Epochs. The group state advances through epochs. Each time someone joins, leaves, or updates their keys, a new epoch begins with fresh key material. This provides forward secrecy and post-compromise security. How messages flow. Commits and proposals. Proposals suggest changes. Add a member, remove member, update keys. Commits and proposals suggest changes. Add a member, remove member, or update your keys. Commits apply one or more proposals and advance the epoch. When a commit happens, the committer generates new key material at their leaf and propagates it up to the tree. Other members can then derive the new group secrets using their position. When a commit happens, the committer generates new key material at their leaf and propagates it up the tree. Okay. So it's, I guess, on the tree, you use keys on either side of the tree to generate the parent node up through the tree. Application messages. Actual chat messages are encrypted using keys derived from the current epoch's group secret. So then there's a root group secret, which is what everyone uses to encrypt messages. Actual are encrypted using keys derived. Okay. Yep. Makes sense. So to get the new group secret during an epoch change, when a commit happens, you have to run the changes up through the tree. Okay. Let's see. I feel like my music is not. Forward secrecy. Wait, application messages. Okay, I already read this. Security properties, forward secrecy. Yep. Compromising current keys, don't expose past keys. After an update, an attacker who had access loses it. Yep. Authentication messages are authenticated to their sender. All members agree on group state or detect inconsistencies. The elegant part of MLS is that it achieves these properties for groups of any size while keeping computational and bandwidth costs manageable, unlike earlier protocols. Required O of n work per operation. I think I have a pretty good idea how this works now. Now it's time to take a look at the plan. Auth and end-to-end encrypted architecture. Happy Groups uses end-to-end encrypted architecture. That's weird reading the appbot plan. Authentication is separated into two cryptographic tiers, a session tier for real-time participation and a history tier for accessing archived messages. The server never sees plain text messages, correct. Metadata minimal, the server stores the MLS public ratchet tree, public keys and pseudonyms, also knows group size, but cannot read message content. Links pseudonyms to real user identities, or correlate pseudonyms across groups. Low friction for daily use. Normal login is email plus password, no mnemonic required for chatting. Normal login is email plus password, no mnemonic. Strong protection for history. Archive messages require a high entropy secret to decrypt. No email only recovery. Email resets server auth, but crypto state requires either an active device or the tier 2 secret. The two-tier split follows naturally from MLS epoch approach. Right. Tier 1 session, tier 2 history. The server gets compromised. Markdown preview. Read like this. So the threat, if the server gets compromised, the compromiser, the attacker, cannot read messages. They can see pseudonyms and group sizes, but not real identities. Email password compromised, attacker gets server auth, but not crypto key. They have no access to it. Password plus device compromised. Current epoch, messages exposed, history safe unless tier 2 secret also compromised. Tier 2 secret compromise. No additional access. Full history access. Full compromise. Password plus tier 2 secret plus server auth. Everything, yeah, they get access to it. Oh. Traffic analysis. Can infer which user accesses which group ID. Guess you could infer this. Hard to do much about that. User password. Email plus password for server auth, server auth. We're on to ID hash stored server side. Client side wrapping key. Tier 1 wrapping key encrypts tier 1 vault, which is the current MLS session state. Tier 2 secrets. Wrapping key. Tier 2 wrapping key encrypts tier 2 vault historical epoch secrets. Do that. Clear at auth and e2. What does historical epoch secrets mean in the context of the tier 2 vaults? Is that the tree? The public keys for the tree? What is the secret? Is it part of the tree? Are you Darcy? Or is this Shauna? Only like one person, whoever joins. I can see that one person has joined, and that's it. Let's see. In MLS, an epoch secret is not part of the ratchet tree. Separate value in the MLS key schedule. Here's the relationship. The ratchet tree holds public-private key pairs at leaf nodes. The ratchet tree holds public-private key pairs at leaf nodes, one per member, and internal nodes. It's the structure used for efficient group key agreement. Ratchet tree holds public key leaf nodes, one per member. When someone issues a commit, the tree operation produces a commit secret. Commit secret is combined with the previous epochs in its secret via a one-way KDF. Commit secret. This commit secret is combined with the previous epochs in its secret. From each epoch secret, so there's an init secret and then a commit secret. The client derives all symmetric keys needed for that epoch, encryption keys for application messages, authentication keys, etc. Every message centering epoch n is encrypted with keys derived from the epoch secret. The derivation is one way. Having epoch secret n gives you no way to compute epoch secret n-1. This is what provides forward secrecy. The historical epoch secrets in the tier 2 vault are simply the saved epoch secrets from past epochs. Simply the saved epoch secret from past epochs. They're the values that the client needs to derive the decryption keys for old messages. Without them, old ciphertext is permanently unreadable. They're the values the client needs to derive the decryption keys. The Tier 2 vault is essentially a key archive that deliberately preserves access to past epochs, working against MLS's forward secrecy property so that the user can still read their own message history. That's why it's behind a high entropy secret. It's the most sensitive thing the user has since it unlocks their entire history. The flow is: tree operations produce commit secrets. Commit secrets feed the key schedule. The key schedule outputs epoch secrets. Epoch secrets derive encryption keys. Tier 1 holds the current. Is the epoch secret the same thing as the init secret? No. Okay. There are different values in the MLS key schedule. The epoch secret is derived first, and then several other secrets are derived from it in a chain. You have the epoch secret, then you generate the sender data secret, the encryption secret, the exporter secret, the external secret, the confirmation key, the membership key, the resumption secret, and then the init secret. And this one feeds into the next epoch. The init secret is the last value derived from the epoch secret. It's specifically the value that gets carried forward and combined with the next command secret to produce the next epoch secret. So the init secret is the bridge between epochs. Are all those secrets derived at the beginning of the epoch, and are they committed as are they the first message in the epoch, or are they derived before the next commit happens? Oh, someone's outside. Some deer. Oh. Okay. All of those secrets are derived at once. At the moment each member processes the commit, that starts the new epoch. It's not a message, it's a local computation triggered by the commit. All those secrets are derived at once. At the moment each member processes the commit, that starts the new epoch. Okay, it's not a message, it's a local computation. Someone creates a commit, handshake message with the tree operations, add, remove. Commit is posted to the group stream. Each member receives and processes the commit. They compute the commit secret from tree operations. Each member receives and processes they compute the commit secret. The operation commit, they combine it with previous epoc's init secret. Grab the entire. The epoch is now open. Members have all the keys they need. Application messages sent during this epoch use keys derived from the encryption key. Eventually another commit arrives, and the process repeats for the next epoch. The commit is the boundary marker. Everything before it is the old epoch, everything after it until the next commit is the new epoch. The key schedule is fully computed the instant you process the commit. Individual message keys within an epoch are derived incrementally from... Stop, hey! Individual message keys within an epoch are derived incrementally from the encryption secret via per sender hash ratchet. The message key 0, 1, 2 for each sender, but the epoch level secret, the one listed in the chain, are all computed up front when the commit is processed. So the users have to keep the init secret until the next epoch. I guess they can always regenerate from the current secret. They were losing. The init secret is just a deterministic derivation from the epoch secret. So if you have the epoch secret, you can rederive the entire chain, including the init secret at any time. There's nothing to lose independently. The epoch secret is the root, and everything else follows from it. In practice, a client would derive the full chain when processing the commit. Keep the relevant keys in memory for the duration of the epoch, and then when the next commit arrives, use the init secret plus new commit secret to derive the next epoch secret. At that point, the old epoch's keys can be discarded from working memory, and the old secret gets pushed to the tier 2 vault for history. The only value that truly needs to be persisted long-term per epoch is the epoch secret, which is exactly what the tier 2 vault stores. And why can't an attacker that knows the epoch secret derive the next epoch secret? They don't have the commit secret for the next epoch. The derivation is epoch secret. It's the init secret and the commit secret. The init secret is derivable from the epoch secret, so knowing epoch n gives you init secret n. But the commit secret comes from the tree operations in the next commit, specifically from the path secrets generated when a member updates their leaf, regenerates the internal nodes along their path in the ratchet tree. To compute that commit secret, you need either be a member who issued the commit, that knows their new private leaf key, or be a member of the group who can decrypt the encrypted path secret in the commit. Be a member of the group who can decrypt the encrypted path secrets in the commit. Each internal node's new secret is encrypted in the public keys of the nodes that need it. I see. So the committer creates a new tree. Or, oh, I see. No, they go up the chain, and then you're somewhere along the chain, and so you just have to go up your own path. And when you go up your own path, you can find the new secret. I assume you go up to the root. I see. That's pretty cool. An attacker who only has the epic secret has neither. They don't have any private leaf key in the tree, so they can't decrypt the path secrets in the commit, so they can't compute the commit secret. They can't derive the next epic secret. Okay. Cool. Awesome. Okay, I understand this one. For the most part. Enough to get started. What else do we got going on here? Gotta make sure this plan is good. Session 1, Year 1 session vault. Protected by the user's password. Derived client side. A leaf private key. Current epic 23. Current epic secret. Pending epic secrets. User's MLS ratchet tree leaf key. Derived from the latest commit. One question I have is, how does something like WhatsApp or Signal prevent a user saying, oh, 2 primary devices? How does something... Like, I assume the user is going to need a primary device and then link devices. How do you prevent the user? 2 primaries. The server maintains a mapping of phone number, registered primary device. You verify your phone number on a new phone, server simply overwrites the old registration, places the push token identity key binding, the old device discovers it's registered. There's nothing stopping 2 devices from cryptographic. The server just doesn't allow it as a policy. Linked devices are different, the primary authorizes them. You choose scanning a QR code and the server tracks them as subordinate. The primary's account. The server enforces a cap on linked devices too. Signal allows up to 5. This is worth thinking about for happy groups because the current architecture doc doesn't address multi-device. The tier 1 vault design implies any device with the password can decrypt it and get the MLS leaf key, but if 2 devices share the same leaf key and both try to send messages or process comments, you get state conflicts, both devices advancing the hash ratchet independently, producing duplicates or conflicting message key. Standard MLS approach to multi-devices, each device is a separate leaf in the tree, so one user has n leaves, 1 per device, each device has its own leaf key pair on the sender ratchet and processes commands independently. The user's identity is the set of leaves they control, not a single leaf. This avoids the state synchronization problem entirely, causes the user taking up more space. I should get my text-to-speech working. Let's try that. Speech. Exits. Stage. CD. Text-to-speech. Each device is a separate leaf in the tree. So no one user has n leaves, 1 per device. WhatsApp allows web, right? I assume every web login has to be a linked device rather primary.
I explained that WhatsApp Web is always a linked device with the phone as the primary, and that the multi-device update gave each linked device its own connection and encryption keys, so the phone no longer has to stay online. I noted that Signal works similarly, and that keeping the phone as the primary simplifies account recovery and avoids split brain issues. I suggested that for Happy Groups, which lacks a phone number anchor, you could either implement a different primary device mechanism or adopt an MLS multi-device model where each device is independent.
What changed with WhatsApp's multi-device update is that linked devices used to need the phone to be online as a proxy. The phone would relay messages from the linked device. Multi-device, each linked device has its own independent connection to the server. But even with that change, the phone remains the only primary. It's the device that holds the account registration, manages linked devices, and is the authority for mobile operations. If you lose the phone, you can't recover the account. The linked devices will eventually stop working. Signal is similar. Signal has been working towards making devices more equal, but the phone number registration is still the anchor. Partly a product decision, not a technical one. Making the phone the primary simplifies account registration. Phone number verification is the identity, prevents weird split brain scenarios. If there's no phone number as an identity anchor, you'd need a different mechanism. You wanted a primary device concept. Skip it entirely and go with MLS multi-device model. Honky tonk. Honky tonk jazz. For Happy Groups, since there's no phone number as an identity anchor, you'd need a different mechanism if you wanted a primary device concept. Skip it entirely. Let's say we skip it entirely. How would we deal with user logging in a bunch of different browsers, computers? I guess we'd have to just limit them and allow them to deregister old sessions. Right, each browser computer login will be a separate leaf.
Each browser or computer login creates a separate leaf in every group, which causes bloat as stale leaves accumulate. And I described cleanup strategies such as a device cap, stale device eviction, manual management, and login time cleanup, along with the necessary vault architecture changes to support per device state and the bootstrapping challenges of adding new devices.
Device cap, server forces a max of say 5 to add 6, so you must remove one first. Device hasn't been active in N days. Any of these are other active devices. Groups. The server could flag staleness. Group has to be compliant since it's pre-operating. Device hasn't been active in N days. Any of the user's other devices. No stale device. User sees their active devices for any session and can explicitly do it for old one. When a user logs in on a new device, the client checks for stale devices. Vault architecture change. The current tier 1 vault's design assumes one leaf user. Multi-device, you need per device state. Probably each device stores its own leaf locally or in a device-specific vault on the server. Messy part is bootstrapping. The first login on a new device needs some existing device or mechanism to add commit. If no other device is online, you need something like a self-add flow using a key package the server holds, or queue the add until the device comes online. The same problem for Signal on WhatsApp solved by requiring the phone. Interesting. Problem. So this is a major problem if you don't have a primary, something like a phone. If you have no primary, then you can't really force any other device to be online. If you have no primary, then you can't really force any other device. Like if the user has only logged in the browser sessions, those may be incomplete. Physical applications. And it's saying you could have server add the device. But if the server can arbitrarily add devices, then it defeats the point of the encryption, because the server could just add arbitrary users to your group and then have access to your group. It's a fundamental tension. Without a guaranteed online...
4 approaches to solving the bootstrapping problem for new devices in a browser-based app, describing a shared leaf per user with server-side send serialization, a per-device queue that waits for an existing device to come online, a self-add method that temporarily impersonates the old leaf, and an option that treats each browser session as an ephemeral single leaf. I noted the trade-offs of state synchronization, latency, and complexity for each, and recommended the shared leaf with optimistic locking, option A, or the simple single-session model, option D, as the most pragmatic choices.
The fundamental tension. Without a guaranteed online primary, you have a bootstrapping problem. The new device needs to be added to the groups, but adds require an existing member to issue a commit. The realistic options. One leaf per user, shared across all devices. All devices decrypt the same tier 1 vaults, share the same leaf, and act as the same MLS participant. All devices decrypt the same tier 1 vault, share the same leaf, and act as the same MLS participant. What? All devices, oh I see. Share the same leaf and act as the same participant. No add commits needed for new logins, you just decrypt the vaults you're in. The problem shifts to state synchronization. If 2 browsers are open simultaneously, they share a sender ratchet. Produce conflicting messages, you would need to server to serialize sends per user. Is ugly but workable for a browser-based app. How about that? It's not easy. One leaf per device. Server key bootstrapping. One leaf per device. Server key bootstrapping. New device uploads a key package and waits. The server stores a pending device add request. The next time any of the user's existing devices come online, it processes the queue and issues a new commit. The new device can't participate until that happens. This could be minutes, hours, or never. So we could just store on the server the primary device leaf keys, and then every other device could just have local ones. And then if you log in, you have to choose whether you're making the thing a new primary. If you make it the new primary, then that's what you have to use to link all the other devices. So I mean, it's just best to use a phone as a primary because you're gonna have your phone with you. And any like website, you're not necessarily gonna have it with you. It has to be online when you're linking other devices. It's not really viable. One leaf per device self-add via vault. New device decrypts the tier 1 vault, which gives it the existing leaf's private key. Oh yeah, I could do that. But if they're both online, option C has the same issue of need synchronization? Or does it not? Because it's just doing that one proposal. Option D, treat browsers as ephemeral, not as devices. Don't do multi-device at all. Each login replaces the previous session. Tier 1 Vault always has one leaf key. Logging in on any new browser invalidates the old one. I don't know if I like that. You couldn't be logged into a browser, 2 browsers. Option A was server side. Option D is simplest if you don't think users need concurrent sessions. I think users have concurrent sessions. What a big deal to not have concurrent sessions. I'm thinking we need to store the main leaf key, and any additional ones could just be on device. Whether we need the device that use it main leaf key, or we can bootstrap manually, I think is the only question. If we can't easily bootstrap manually without potential state issues, then it seems like we should just require a phone to be the main primary device that uses that leaf key to add additional
explained
new
that
device-
option C avoids ongoing state sync issues because it is a one-time operation, but it can still conflict if the old device is online during the brief window when the leaf key is being replaced. I argued that storing the main leaf key in the Tier 1 vault makes using a phone as the primary device the simplest and safest solution, while noting that a server-mediated lock would add unnecessary complexity.
And both devices have their own independent leaves going forward. After that moment, the old leaf is replaced. Each device operates independently with the state. The only risk is if the old device happens to come online and try to use the old leaf during that brief window. Can a new device safely use the main leaf key to issue the ad for itself? What if the device that's currently holding the main leaf is online and actively using it? The new device decrypts the vault. The new device issues a commit while the old device is mid-operation, you get a conflict. Can't safely coordinate without a live device. So the phone becomes the lock. Pretty funny. Phone is always the owner of the main leaf. It's reliably reachable via push notifications and connect process. Reliably reachable via push notifications and process. Add my new browser session request. Phone is always the owner of the main leaf. It's reliably reachable. It can process add my browser session. The alternative would be a server mediated locking. New device requests a main leaf lock from the server. Server revokes the old device's ability to send until the bootstrap commit is done. New device is added. Yeah, what happens if you get a deadlock? The server can't. Can the server resolve it? I don't know. Maybe. So break down our two options. Server mediated lock and primary. Yeah, server mediated lock is pretty nice because it would mean you could log into a browser without having to have your phone on you, which is pretty cool. Otherwise, you have to have your phone on you to link a new device.
I need some content to clean and convert for text to speech. Please provide the text you'd like me to work with.
Why does that keep happening? Text to speeches. Wonder if it's maybe Grok, GROQ that's having issues. Look at it. Server mediated lock, no primary device. New device logs in, decrypts the tier 1 vault, gets the main leaf key. New device requests a main leaf lock from the server. Server grants the lock, rejects any operations from other devices using the main leaf until released. New device generates its own leaf key pair. New device uses the main leaf to issue add new device, update main leaf, commit for every group. New device re-encrypts the vault with the new main. Wait. New device uses the main leaf key to issue add new device, update main leaf to a fresh key, commit for every group. So I guess with this setup too, the downside is that every device gets access to your primary leaf key, which you may not want. Like, you may not trust the browser or like computer you're logging into that much. So you may not want it to have access to your primary key, your primary leaf key, the one that lets you remove other devices and stuff. It's kind of cool too, because the way this would be set up, where you have your history separated from your login, it means if you were to log in on a computer you didn't really trust that much, you could log in and just message people without having to pull in your whole history. Add new device, update main leaf to a fresh key, commit. New device re-encrypts the vault with the new main leaf key and uploads it. New device releases the lock. New device re-encrypts the vault. New device releases the lock. Old device comes back online, refetches the vault, gets the new main leaf key, processes the commits from the stream, continues in the server grants the lock. New device generates its own leaf pair. New device uses the main leaf to issue. Add new device. Update main. Commit. Partial failure problem is the hardest part, but you could make the bootstrap atomic by treating it as a transaction. If any group add fails, roll back the one that succeeded and remove the wall. New device logs in, generates a key package, uploads it, signals I want to join all my groups. Server sends a push notification to the primary device, wakes up, fetches the new device's key package, issues add, sends a welcome message to the new device's mailbox, new device receives welcome, has its own independent leaf in the group. Clean semantics, no locking, no partial failure, no vault key rotation. Yeah, I like option 2 because it also means that there's no risk of your main key getting leaked on a less secure device. So the most secure device can still be the authority over which devices can be added or removed. If every device that logs in has access to the primary leaf key at some point, then they could remove other devices at any point. Option 1, every device that's ever bootstrapped.
I explained that keeping the primary device's leaf key on the primary, only option 2, provides a stronger security boundary, because compromised browser sessions can only act with their own leaf keys and cannot impersonate the primary or remove other devices. I described the permission hierarchy, where the primary device is the admin that can add or remove devices, while linked devices can only send and receive messages. I noted that the server can enforce this by recognizing the primary leaf in the user's account record and rejecting unauthorized removal requests.
So we have to keep track of the other devices. The user vault or what?
There is no content to process. Please provide the text you would like me to clean for text-to-speech.
What is wrong with my text-to-speech? Weird. Never had that issue before. The master vault is in the natural place. It already tracks group membership. Extending it to track device fits. There's attention. The master vault is encrypted to the tier 1 wrapping key. Every device that has the password can decrypt and modify it. You need the server to be involved in enforcement, otherwise a rogue browser session could just edit the vault and click primary. So you'd want 2 layers. Master vault, the user readable device list stored encrypted. Any device can read it to show your active devices. Primary updates it. When adding or removing devices. Server-side account record. This server tracks device ID. The account knows which device is primary. The vault is just client. Convenient copy of the device list and knows which pseudonyms. Okay. These are vaults. Your vault contains the leaf private key. Any device with the password key decrypted. The browser session that logs in gets the password, decrypts the tier 1 vault, and now has access. It's the whole point of option 2. Primary leaf key can't be in vault, it has to stay exclusively primary device. That means the tier 1 vaults with account vault. Device locals. Master group list devices. Device local state. That device's own leaf private key. epoch state, sender ratchet position. The primary device's leaf key lives on the primary browser session leaf key. No, only in that browser. For which no device ever happens to another. The whole point of storing group history is so the user store it, which requires leaf key to be on my head. Now, the epoch secrets stored in the tier 2 vaults are self-contained. They don't require any leaf private key. You just need the tier 2 secret. The vault itself, and then each epoch secret directly. The leaf private key was needed at the moment, and it was processed to participate. After the duration happened, the epoch secret say every server with a lost primary device, user enters tier 2. Decrypts tier 2 vaults. Read the old messages. User sets up a new primary device, generates a new leaf key pair, user gets re-added to group. Those are a couple. User logs in on a new device with email password. Client derives tier 1 wrapping key, such as in decrypts tier 1 vault. The phone is lost. The user needs their tier 2 secret to recover history. How do they establish the new primary? They lose their... Don't. A new primary device creates a brand new leaf key pair and starts from scratch as an MLS participant. The problem is getting re-added to the group. Without any active device, no device can issue. Same recovery flow already in the other. Reset password, tier 2 secret history. Tier 2 vault contains the group list. Device generates a new leaf year. Dock, handwave, step 7, 8, client fetches. Process up, but that assumed a single leaf model where the vault had the leaf primary only leaf key model, both leaf keys. The user is effectively a new member. You need another group member to add them. Server knows which group. Why not save the primary? I think for any... Hmm. To link devices. With something complicated like this, it feels like the AI kind of spins you around in circles because it leaves out details because you don't know what to ask. So if you already know what should happen, it's very useful to just, because it just gives you the plan that you explain to it. But yeah, when you don't know exactly what you want, you're just kind of going around in circles. Okay, that's a clean solution. Because the primary leaf key is stored in the tier 1 vault, recoverable by entering the password. Only the mobile app accepts email, password, passkey login, so only a phone can decrypt the vault and access the primary leaf key. Browser sessions are linked via QR code. The phone scans the QR, issues the add commit, sends the browser its own device-specific leaf key in session. The browser never enters the password, never derives the wrapping key, never sees the vault contents. What each device has access to. Phone, password. How would we allow syncing history? Also, we would still need some kind of user metadata vault browser to know groups there's in. The phone links browser adds the browser to each group. Oh. The browser receives welcome messages for each group. Those contain the current group state, the current epoch branch, the browser state snapshot. The browser discovers its groups through MLS. For history, the browser can't access the tier 2. At link time or on demand, the phone shares selected epoch browser. Phone could prompt share history with device on the browser. Browser stores those epoch secrets locally and can decrypt. Browser phone must be on. The phone remains the authority. I think the phone would just ask, do you want to share all history? Or maybe specific. Share. That work? At link time or on demand, phone shares selected app. The flow would be at link time. Phone scans QR code. Phone adds browser to all groups. Phone prompts share message history. All groups, select groups or none. If sharing, phone unlocks tier 2. Grabs the relevant epoch secrets, encrypts them to the browser's leaf public key. Browser user scrolls back, browser sends a hit. I was thinking, what do you think? For link time for the phone, let's have all the keys that are available. For on demand, I meant more these are above. I think app. On the first point, yes, the tier 2 vault on the server has all historical epoch secrets. The phone doesn't store them all locally. The phone decrypts the tier 2 vault when needed. The flow is phone pulls the vault from the server, decrypts it, extracts the epoch secrets. Selected groups, encrypts them to the browser. Tier 2 vault. I forget to phone's local storage only needs the tier 1 state. Tier 2 is always fetched from the server and decrypted on the end. If the tier 2 vault itself gets too large, user in many groups, server storage problem, you can have big printing. The tier 2 vaults are per user per group. And the second point, all right, on-demand history sync isn't true. The user explicitly going to device management screen, sync history to the more like a settings action. Looking back at the architecture, actually one vault with all groups in it. That's one blob. Every time you update it, you decrypt the whole thing, modify it. For the history sharing use case, it's a bit awkward. Putting it into per group. Like, and then the tier 1. Right, the master vault already has the group list, so you just add a reference to each group's tier 2. On the server, vault, whatever, it's in it, using random IDs rather than deriving from the group ID. The server can't correlate tier 2 vaults. When sharing history with a linked device, the phone looks up tier 2 vault ID for the selected groups in the master vault. Fetches, encrypts just those two. When a new epoch happens, the phone knows exactly which tier 2 vault to update for that group. The user leaves a group, you delete that group's tier 2 vault. Okay, go ahead and update the doc. Yes. This setup is kind of annoying because I'm gonna have to get login working on phones first, because on the browser you're only gonna be able to link through a QR code. I think probably temporarily I'll just add the login to web. Kind of weird though, because all the front end flows for that will not be used. But it's much faster for me to develop.
I explained that the problem stems from the remote server being IP6 only, causing a cosmetic TCP/NODLAY warning and a real connection failure, because the SSH tunnel resolves localhost to different address families on each side. I suggested fixing it by explicitly specifying the IP6 loopback on the remote and the IP4 loopback on the local machine in the SSHR command, and I recommended verifying which address the TTS server is bound to.
Settings. Then on
narrated a tale of Kale, a young forest warden who uncovered an ancient crystal that revealed visions of a lost era and warned of a failing seal, prompting her to journey with a witty talking fox and a disgraced knight toward the Spire of Whispers. Along the way, I showed how the bonds of unlikely companions became the true source of magic, ultimately allowing their friendship to defeat the encroaching darkness and bring a new dawn to Ethermore.
And here's a summary of the primary device versus devices. Server-side device tracking. Tree sharing. So the server knows how many linked devices. The server doesn't know which user.
There is no content to clean. Please provide the text you would like me to process.
Doing it. Doesn't know which user has which devices. The device registers per account. It needs to know this to enforce the device. Yep. Primary. The server knows devices. Not knows which of those devices group. The server knows you have. I think we have any maps in our. Do you think? Basically.
It seems there is no content provided. Please provide the text you would like me to clean and convert for text-to-speech. I will remove markdown formatting, code blocks, and expand abbreviated units and file extensions as requested.
Quad code must have broken the hooks. There are a few gaps I'd flag before implementation. Some things... A group invitation with... When someone else invites the user to a new group, a welcome arrives in the mailbox that a primary device processes it. Primary also group, and then welcomes. This multi-step flow is in document. Here at one group invitation with multiple. Someone else invites these. I think we haven't thought about how you even find these. So add them email. You search for it. Username. Per user per device mailbox. The dock has one mailbox per. Device has. Dock has one mailbox per user with multiple devices who monitors it. A welcome. Primary picks up a welcome and processes the linked devices. Probably need either per device mailboxes or a rule that the primary is the sale mailbox consumer and distributes. Mailbox. I think probably each device has its own mailbox. Primary is responsible. Or primary offline epochs. Primary device is responsible for promoting epoch secrets to tier 2. Does this by processing stream. Primary device is responsible for promoting epoch secrets to tier 2. Does this primary is offline long enough, the commits get purged from the stream. we can have your members. Think about user uses history, but if they got a linked device that they wouldn't actually. Four, notification strategy. Doc doesn't mention how the primary device is woken up from ends. Without push notifications. I don't know how those. 5. Barcode security. The linked flow establishes encryption. Safety number. Display. Session tokens. What can a linked device do? Messages from own linked devices. When the user sends a message from their laptop, their phone receives a message from the client. No. Master Vault has this mapping. The primary can read devices would need. Probably fine to resolve during implementation. later. Epochs big secret promote. Okay. Oh my god, a lot of content.
I explained the design decisions, covering a user discovery model that combines usernames with invite links. Per device mailboxes, where the primary device forwards group invitations, the handling of epic secret loss when the primary is offline, a push notification approach that sends tombstone alerts without message content, QR code linking that relies on physical scanning for security, session token scoping that limits WebSocket and mailbox access, the use of pseudonym mapping during device linking so messages from a user's own devices appear as you, and the fact that browsers generate their own leaf keys without exposing private material.
Device mailbox with primary. Go with per device mailboxes where the primary is the sole recipient of invitation. The inviter only needs to know one mailbox ID per user. It's in the public. Device group members. Primary process. That's the three platform. Names. We probably need numbers to them. Cool. So I have to account for being able to how do other members know messages are from the same person? They don't know if the person is the same user. If they don't know about this is user, because they're all using. Three. Epic secret loss when primary is offline. Read other members can retransmit. The important thing is to document the consequence clearly. If the primary is offline long enough, the commits get purged. Those epic secrets are lost from tier 2, and the corresponding historical message permanently uncryptable even with the tier 2 secret. The link device had the secrets ephemerally but couldn't persist them. Or push notifications. iOS, your server sends a JSON payload to Apple servers, Apple delivers to the device. Android, Firebase cloud messaging similar, your servers Google delivers. Web push API, browser registers a push subscription endpoint, your server sends endpoint. Ratchet encryption, the push payload cannot contain message content. Those approach. App wakes up, connects to the server. Each device registers a push token. When the server receives a new message for a group, it pushes to all devices that are members of that group. The server already knows device to account mapping in group membership at the pseudonym level, so it can route push notifications without learning message content. The primary device specifically push on mailbox items. QR code linking security. Right, for the device linking, the security is simpler since you're linking your own devices. The physical act of scanning the QR code is the authentication. The threat model assumes you're physically present on both devices. The hacker would need to replace the QR code on your browser screen. Good. Session token scoping. Can design during implementation, but roughly the token should authorize WebSocket connection. Although you still want, I guess it has a one. Temporary public key, not session ID, phone scans it. Some confirmation on the primary device before doing the linking. That way, scanning a random. Six. Session token scoping can design during implementation, but roughly the token should authorize WebSocket connections, receiving group messages, and fetching places of mailbox. It should not authorize. Good. Messages from own link Signal and WhatsApp handle this with sender key distribution. Each device distributes its sender key to all group members. I see. Didn't I ask? Oh, I did down here. Seven. Signal and WhatsApp handle this with sender distribution. Each device distributes members. Device B receives a when device B receives each device first. During device linking, the primary shares the second. During linking step 6-7, also sends the mapping group. When the linked device receives a message from member XY, renders it as. Yes, the browser generates it. Sure. At all devices. Browser generating leaf key. Yes, the browser generates it. Private key never crosses the device boundaries. Phone only sees. Here's remaining open question. Is the epochs secret promotion from linked devices secret promotion from linked device? Only the primary promotes to tier 2. Only primary promote.
I explained how usernames use unique numeric suffixes and can be changed without affecting group identity. described that encrypted group state snapshots let members recognize multiple devices belonging to the same user while the server cannot correlate them. Detailed a QR code linking flow that includes a phone confirmation step. Outlined how the primary device propagates pseudonym mappings to all linked devices to keep them in sync. And offered to update the architecture document with these decisions.
Server maintains a mapping. Your name. In groups, the server identifies that the members want. Important design point. The answer is an encrypted group state snapshot. So then, why not just Primary adds a new linked also updates encrypted group state and to include the new pseudonym. Remembers process the and update the queue. That's if we want to use username, then sure. So members.
Conflict, confirmation before linking. Yes, the flow should be browser shows QR code, phone scans, QR code phone display confirmation. User explicitly confirms. Only then does link proceed. Good. Keeping synonymous pseudonym mapping. Primary distributes pseudonym map. Each linked device's mailbox. Events that trigger an update. New device linked. Primary sends current pseudonym. Events that trigger. Linked. Primary sends current pseudonym. So thinking
It seems there is no content provided. Please provide the text you would like me to clean and convert for text-to-speech. I will remove markdown formatting and code blocks, expand abbreviated units, and expand file extensions to full names.
username in groups and change location. Right, members want to see usernames, not pseudonyms, but you don't want username change. Map pseudonyms just never changes. Your profile username, display name, avatar. Member XY. Profile. Server. Receives. Hmm. Hmm. Is there any way to close profile? I guess the server has to be able to, for you to be able to serve. Initial bodies profile. Yes, we could. That would break. Signal. So your photo name could make only. Seven. 3. No, 7. Retransmits for stale full. Pattern should be link device is sync. Link device sends a sync. We could start. 2.5 hours now. Okay. Oh.
I explained a tiered profile visibility design like Signals, where only the username is public for discovery, and all other profile data is encrypted with a profile key that's shared through the encrypted group state. So group members can decrypt and see full profiles, while strangers see just the username. I also described how rotating the profile key lets users limit future updates to current groups, providing practical revocation without exposing profile details to the server.
Already knows your name. Profiles are public, or also see your display name. There's your email. What other users? This is a more interesting question. Fully public profiles, anyone who knows your identity username can see your display name and everything. And people not encrypted. Signal encrypts profiles. Profile. Share your profile key with contacts and groups. People who don't have your profile key. Join a group, your profile key is distributed. Tiered visibility similar to Signal. Public, username only. Yeah, I like that. When a stranger searches for Jordan, server return Jordan 42, user only. They can send a group invite to this username once in a group together. Profiling. So that setup basically means there's not great discoverability. You would have to know the person's exact username, and you wouldn't even see an image or anything for them. How would you be sure you're inviting who you think you're inviting? Doesn't feel degraded because the server never sees display names or avatar. Avatar. So in this setup, you can't search for. I need to think about how much do I care about public groups, being able to find groups that aren't encrypted. Just as soon as I have public groups, I have to deal with moderation issues. With private groups, they're not searchable. Don't even know what the name is, but someone can invite you to one. But I think if I eventually wanted to support public groups, then you're going to have some kind of public profile. I want to eventually public So I think pretty much eventually need a con. Even if our
There is no content provided. Please provide the text you would like me to clean and convert for text to
this work
speech.
every other. That's a good point and simplifies things. If public groups privacy question. Well, meaningful privacy boundary for private groups is membership and content, not profile visibility. Got it this way. The server already knows your user. Public groups exist. Any user who participates in one has a visible identity anyway. Signal encrypts profiles because Signal is exclusively private. The public groups. For the cleaner design, profiles are public group membership and private groups. Public server can see, anyone can click username, your display name, your private server cannot see which private groups you're in, message content in those groups, and the pseudonym to identity. What the server doesn't know, Jordan42 is a member X. Okay. Learns Jordan has an account. They don't learn what private groups Jordan has said or who Jordan talked. Profile being public adds no meaningful attack surface. Already knew the account. I like this. You go ahead and document creates, asks, updates. All right, so I can make profiles and log in. Real profiles, not mocked up ones. It'll be interesting if I get the private groups fully done and encrypted, like, because the public groups wouldn't exist yet. I wonder how the discoverability would be. Like, would it be very hard for something like that to be viral? Because you can't find groups to join. Like, you have to create groups with people you already know. Kind of like that better. That, like, any group you have is actually like a real group of people you know, not some group you found online. But yeah, it makes it harder for the app to grow quickly. It'll be interesting to see how fast, if people like it, how fast they end up using it. Or rather slow. How slowly they end up using it. I know for myself, there's already groups I'd want to create.
Here's a summary of everything that was updated. New sections added. User identity recovery. So let's start coming up the basic implementation. We already have a web front end. I think we should start to add login to this. We won't keep it around long term, but we can iterate faster on web before we do mobile and the linkings. Then from there, we can do profiles, user vaults, start building out groups, mailboxes, user group vault. Public group states. Come up with a few stages. We build these out. Chunks. You can do this. And a new separate doc. The arc. RC, I assume you're the only one watching. If you are, how do you feel about the music? Because, I don't know, I think I gotta start finding new music that just keeps playing over and over. Yeah, I'll try to find some more, maybe tonight or tomorrow. It's just a pain to find royalty-free music. I like this music, it's just, there's only so much of it. Yeah, I think that would be the thing to do, would be actually to find more classical, because a lot of the classical music is royalty free. Are you working from the Bay Area or somewhere else? There's like a, I think there's like a 5-second delay on the stream. I tried to use the ultra low latency, which is maybe like a 1 to 2 second delay. But the issue with the ultra low latency is that you can't do 1440p streams. You have to limit it to, I think, like 1080p. Because I have such a big screen, it's hard to read what's on the screen if you enlarge it. Yeah. West Bay, down LA. Which do you like better, LA or the Bay Area? Done. Foundation. Web login. Okay, so pages. More alone in LA. Yeah. I used to drive Uber in LA a long time ago. When I used to live in LA, I went to Long Beach State, and then after Long Beach, I like tried to get a job in software engineering, but I didn't know anyone in software engineering, and I had done a chemistry degree. And so, yeah, I like learned software engineering, like making websites and stuff while I was in college on my own. And I like applied to 3 or 4 companies and I didn't get any interviews, and I didn't realize you had to apply to like 20 companies because I didn't know anyone who did that kind of thing. And so anyways, after that, I just kind of did random like consulting jobs doing software engineering for really small startups, so hourly. And that was fine, but I didn't really like working for startups because most of the startups are going to fail and the people don't realize they're going to fail. So it's like, it's just hard to be working at a place where you're like, all of this work is going to be worthless because you're not. What a crucial. More like 0 company, 100 companies probably is the. It says 0 companies, but I imagine you meant to say 100. Yeah, so yeah, like I said, when I applied to like 3 or 4. I applied to like Google and Facebook, and I like didn't hear back, and I was like, oh, I guess I can't get a job. I might have applied to a couple other places, but yeah, I didn't get any interviews. And then then I worked for the smaller startups. There were like 5 to 10 people startups, and they maybe had like a couple $100,000 or so, and they'd pay me hourly. And then, like I said, it's just hard to work at a startup where it's just very obvious the startup's going to fail and none of the work you do matters. So like the thing for me with the Happy Group stuff is that even if I made no money, like if I could get this done and put it out there and like any amount of people use it, it would be worth it to me. But most of the startups I worked for, like they wanted to get big and make a bunch of money, and it just like, wasn't going to happen. Like they weren't doing the things necessary to make that happen. And it's just hard to be doing work on a website or something where you're like, oh, this is just going to go in the trash in a year when you run out of money. So anyways, after that, after I got tired of that, I decided to just drive Uber for about a year. Because Uber was paying pretty well. They were paying drivers more than the passengers were paying for a while. And so you could make like $40, $50 an hour driving Uber, which was pretty good. And I liked driving, and it was a fun thing to do. So I drove all over LA for about a year. And then Uber started ratcheting down the prices the amount they were paying the drivers and ratcheting up the prices they were charging customers. And then there was like a certain point where I knew ahead of time that it wasn't going to be worth it if they lowered the prices enough. So then after that, I did other stuff. I did a little bit of machine learning stuff, and then started the master's at Waterloo, and then left to do a bunch of different things. Yeah, so anyways, drove Uber around LA. I would do like Friday, Saturday night. I do like 12 hours Friday, 12 hours Saturday. But yeah, LA, the issue for me with LA in general, is like especially driving around, is that if you live near one of the beaches or anything, or I mean, most of LA, you can drive 40 minutes in any direction and there's still people. There's still a ridiculous amount of people. Like, it's just crazy how many people there are in LA. Like, I mean, yeah, they can't pay any money to drive. They can't pay me to drive around LA now. The funniest thing was I didn't see very many accidents. Like, I drove for a year or so, so I spent a lot of time on the roads, and I thought maybe I'd see some accidents or whatever, and it didn't happen too much. The main place I saw accidents was actually at the airport at LAX, because people drop someone off and then they kind of pull out, and I saw like probably 3 accidents at LA. Not major accidents, but just like someone's pulling out because they just dropped someone off and runs into a bus or something and like dents the bus. But yeah, I mean, it's not as bad to drive around LA if you don't have to be anywhere, right? Like, you as the driver, if it takes 15 minutes or 30 minutes, that's not up to you, and you're not the one late for whatever thing, right? So it's not that stressful as the driver. It's definitely a lot more stressful if you're the person that's like, I gotta be wherever I need to be and traffic's not moving. But yeah, that was always the hard part for me with LA, was just how many people there are. It's just so crazy. Like, you drive from LA to San Diego and there's just houses the entire time. It's just, I'm like, there's so many people. It's crazy. And then the funny part is, like, even driving around LA, there were maybe like 3 passengers in that year and a half I did Uber where I had picked them up before, which is pretty crazy. So picking up, I guess there's probably not everyone in LA uses Uber, right? So especially earlier on when they were paying more. So probably it's like a subset of the population that even uses Uber. So you're more likely to pick up people, but it's just kind of funny to pick up someone multiple times in like completely different parts of LA. Okay, what is the design plan here? I'm gonna go grab some water. I'll be right back. With each stage produces a working testable system. Crypto is layered on after the core UX loop works. Current state, React 19 frontend with mock data and 60 plus UI components. Phoenix 1.8 backend with health checking.
Got me as well.
Okay. Incremental build plan, React 19 front end. Preview. Crypto is layered on after the core UX loop. React 19 front end with mocked data. Start with web-based build login. Web-based email. Do I want to do patties first? Do I want to do email? Hmm. You kidding me, Ruby? Database schema. Good plan. For stage 1, are there separate bucket? Are there libraries we should be using for this stuff? Feel free. Use context. To be a creator. We need JSON API endpoint. Similar. Got enough beds. Thinking about it, if we support public active groups, road, likely maybe we should using it now. So Peter. Definitely. Massive relational data. Hmm.
What percent?
It appears there is no text provided for me to clean and convert. Please provide the text you would like me to process.
Server has the public right. Doesn't map student to authenticated what? The server doesn't inherently know. Set up the server. Listen.
grep the auth and d2e architecture markdown for the phrases server does not know, pseudonym to user, traffic analysis, and mailbox, and I displayed the surrounding 2 lines of context. The output showed that the server never learns users, real identities, that a pseudonym to user mapping is kept client-side, that the design mitigates traffic analysis, and that mailbox handling is described.
Architecture already has the answer. Mailbox based by subscribe. Plans are updated. Page 3. Here.
I explained that the haplogroup server has 0 type definitions in its 14 Elixir files, describe the 2 parallel type systems in Elixir, traditional type specs with dialyzer, and the new gradual set theoretic types that are inference-based and already active in Elixir 1.19.5, and recommended updating the Elixir version constraint to 1.19, adding warnings as errors. True to enforce compiler warnings, and optionally enabling credos, spec check, and running dialyzer for additional coverage.
Type spec. This Elixir's new feature, the roadmap from the full type depends on all cons. System tracing API. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. 'No annotations to write the compiler in first type. ' It's warnings automatically. You've already. What you get today? Compiler automatically types and smash. Using non-enumerable. And enable now for the we already do server
Permission requested. Edit mixex's file in the Kiwi application. I updated the mixex's file to bump the Elixir version constraint to 1.19 and added warnings as errors to the Elixir options configuration. I edited the credox's file to move the credo, readability, specs check from the disabled list to the enabled list, and cleaned up the surrounding check entries. Finally, I read both files to verify that the changes were applied correctly. I compiled the Elixir project and saw no warnings. Then I ran Credo in strict mode, which reported 21 issues, 19 missing at spec annotations, and 2 missing at moduledoc tags. Do you want me to add the at spec and at moduledoc annotations to fix these, or would you prefer to roll those out incrementally?
file passes. Do we not go? Already wired up in tag elixir. The lint task depends on both lint credo, x strict run.
I read several Elixir source and test files, added missing at spec annotations, and at module.epoch tags across modules like telemetry, plugs, controllers, and the getExt and echo channel modules, and then ran mixcompile followed by mixcredo in strict mode to verify the changes.
Yo. Move from that. Oh.
I edited the link's elixir file to replace type specifications with struct patterns for functions like delete link, restore link, record hit, and change link. And I restored the struct constructors for link and link history in the changeset calls. Then I compiled the project and ran Credo in strict mode twice, both times passing clean, and I proceeded to check the dialyzer analysis.
What? Checking my. All right. Stand. Mike. The TypeScript front-end project.
I made a commit without verification that adds at spec type annotations and enforces type checking for galinks, includes a bump of the elixir version, and records these changes in the commit message. The commit message details the new feature and the version bump.
Public / protector stages will have queries starting with GraphQL. Now avoids migration later.
Permission requested. Command to check if styled system is tracked in Git. explained that the styled system directory wasn't tracked in Git, which caused the typecheck moon task to fail because panda cogn wasn't run. I added styled system to the gitignore, inserted a cogn task into the moon, iml YAML that runs pnpm panda cogn and made typecheck depend on it, and then I executed the moon run kiwi. App, happy groups, web, typecheck command to confirm it now succeeds.
You don't need the gitignore since it's already defined in the root gitignore.
I displayed the staged changes and their statistics, showed the full staged diff, and then committed the updates with the message adding a cogn step before typecheck for the happy groups web.
Okay. Can do some stuff.
Come on. Hello.
Permission requested. Execute exit plan mode with implementation plan for auth foundation.
Yes. Parallelize what you can by using.
Permission requested. Command to install urql and GraphQL npm packages. Permission requested. Command to run panda codegen and TypeScript typecheck. Permission requested. Run EaseLint on web project. Permission requested. Run EaseLint on web project. Permission requested. Run panda codegen and TypeScript typecheck. Permission requested. Run panda codegen and TypeScript typecheck from the web directory. I edited the layout TypeScript file to adjust an import line, ran panda code generation and TypeScript typechecking. That background task was the earlier test run, already captured in my results above, 27 tests, 0 failures. The implementation is complete and fully verified. No further action needed on that notification. There is no text provided to convert. Please provide the text you would like me to convert for text-to-speech. Permission requested. Command to clean and recompile the Happy Group server project. I forced a recompile of the Absinthe, Absinthe Plug, Absinthe Phoenix, and Argon 2 Elixir dependencies. Then I cleaned the development build directory for the Happy Group server and recompiled the project. I ran the pending database migration using the mix-ecto migrate command and captured its output.
There we go. Now it's working. Let's see. We still want to show the feed and everything, even if logged in. Let's put the login route /login. Because
I removed the import of protected loader and the client loader export from the layout TypeScript file, leaving only the styles import. This makes the app fully accessible without requiring login, while keeping the login and register roots and preserving protected loader for future gated routes.
there we go. Login, and then we this. Let's go. Yeah. Oh. I'm trying to think. Yeah, so this shouldn't work. What are username suggestions? Username suggestions. Get user paste. Graphical interfaces all that stuff. Arguments. No, just yep, works. Okay. See if this will. Oh, this is the register page. I want to see what happens on the login page. Yep.
many times can I try? I don't think we have any rate limiting. Do we have any rate limiting on invalid login attempts? That didn't work. I think a base name will suggest available username. Did not work. Words. Wait to see. Auth. User function has timing attack prevention, but nothing limits repeated attempts. This is worth adding, but has a few design choices. Want me to plan an approach? The simplest server-side option would be to do per IP or per email. Login resolver that returns errors after end failures within the time window. Yeah, we definitely want to do per IP. Let's do per IP. We probably need per IP and also cores errors. Ping shouldn't be an auth route. Post. Work. There we go. Now add a rate limiter application supervision tree and wired into the log. Rate
I
limiter.
updated the Corsica configuration in the Elixir endpoint file to include a regular expression that matches if 6 localhost addresses, added a new Elixir rate limiter module using ETS, integrated it into the supervision tree, modified the absinthe context plug to pass the client IP, and updated the login resolver to enforce per IP and per email rate limits. Then I compiled the project and ran the test suite, and all 27 tests passed.
Ping. Community.
I read the user sockets file and edited the connect function to make the token optional,
What is
allowing
the
unauthenticated users to connect anonymously while still handling authenticated users. Then I compiled the project and ran the test suite successfully.
The name format is base.n. When a user types in a base name, base is lowercase, non, three random are generated. Weakness is that it generates exactly count candidates. It's an issue to let a user specify the including digits. Like if I wanted to specify. Also, this has no dark mode selector. Server suggests user must pick from two. The user never gets to type Jordan O. Correctly, the plan says user picks from submission. Technically, a client could submit. Yeah, they should be allowed to type in a name include. Also, we need light dark mode. What's this called? Theme selector. Theme web slash theme. Login register pages. Probably in the top right. Maybe we need a logged out. Oops. Slash header. And the balloon be bouncing. Shared auth page, a free text username input, update both pages, and the balloon. Oh.
Permission requested. Run codegen, type check, and lint on the Happy Groups web application. the shared auth layout TypeScript JSX component with theme toggle and a bouncing balloon, updated the login page and register page TypeScript JSX files to allow free text usernames, and then ran a bash command that performed panda code generation, TypeScript compilation without omitting files, and ease lint-linting, confirming that the project builds successfully.
Need some kind of validation on both the client and server about formatting of the name digits. And then feedback for the user. Either one is failing. We're going to run out of context, so can you make some detailed tasks, and we'll go ahead and compact, and compact, and then continue. Status, connection status. Can we just make this not include any interval that happens as soon as the...
I created 4 tasks to enhance registration validation, making the GraphQL register mutation return structured per field errors, displaying those errors on the register page, aligning client and server username validation, and adding client-side password and email validation feedback. I updated task 2 to be blocked by task 1 and task 3 to be blocked by task 2, establishing a sequential flow for the first 3 tasks, while the 4th can be done in parallel. I outlined the dependencies and the plan to compact the work when ready. I updated the usesocket TypeScript file, replacing the visibility change listener with focus and blur listeners on the window, changed the event removal to use window remove event listener for focus and blur, and switched the initial join check to use document has focus, so that pinging stops on blur and resumes on focus.
Does it ignore any interval that starts with in progress when the blur happens?
I edited the usesocket TypeScript file to set resumed@ref current to the current timestamp on blur before stopping pinging, fixing the gap where latency stats could be updated while the page was blurred.
And is this using the design? Register page. Yep, let's use system. Full name.
Permission requested. Command to type check web application. Permission requested. Type check web app from the Kiwi research directory.
Go away, Bitwood. Yeah. Please unblock display per field server validation errors on the register page. Validation error.
created the register page TypeScript file to replace the inline validation regexes with username regex, email regex, and password min constants, then ran the TypeScript type check, applied lint fixes, updated the task status, and executed the full server test suite along with lint and type check verification, all of which passed. I explained that the username currently has no length constraints beyond its format. Do you want me to add min-max length constraints? For example, base part, min 2 chars, max 20 chars. Digit part, min 1, max 4 digits. Or just an overall username max length, e.g. 24 chars. Permission requested. Ask user for base username max length. I updated the username generation in the Elixir accounts file to use a suffix between 10 and 99,999. Changed the username regular expression in both the Elixir server file and the TypeScript client file to require 2 to 5 digits, and added a maximum length of 32 characters. And I modified all test fixtures and related tests to use 2-digit usernames. I then ran the server Elixir tests and the web TypeScript type check, and all 28. I explained that the regex AZ0-9 plus \, 0-92, $5 only matches lowercase characters, the client lowercase's input before sending, and the server validates against that same lowercase only pattern, making the system effectively case insensitive for normal usage, but rejecting uppercase letters sent directly. I offered to add a server-side step that downcases the username before validation, so that inputs like Alice42 become Alice42 instead of causing an error. Should I add that server-side downcase normalization? read the register page TypeScript file, edited the input component to include max length set to 32, and then ran the TypeScript type check. I confirmed that the username field now enforces a maximum of 32 characters in the browser.
Be checking slash debounce. Should be checking debounce whether and valid.
Updated register page TypeScript to show checking and available hints, reflect availability errors in the username input, display suggestions when the username is taken, and disable the submit button while checking. I then ran the server test suite, type-checked the web code, and applied formatting and lint fixes, confirming all tests passed and the code type-checks cleanly.
Talking about me. What you wagging about? What you wagging about?
redirect if logged in effect to the login page TypeScript JSX and register page TypeScript JSX components by importing useEffect, pulling user and loading from the auth context, and navigating to the home route when a user is already authenticated. I also reverted an unnecessary import change in register page, and then ran the TypeScript compiler in no emit mode to verify the code type checks. I added the useNavigate import and integrated useauth's logout function, updated the component state to include the navigate hook, and replaced the placeholder logout handler with a call to logout and navigation to the login page. Then, I ran the TypeScript typecheck command to verify the changes.
What did I use? Frick.
Permission requested. Command to find SQLite database files. I navigated to the server directory, listed any SQLite database files, and queried the user's table in the development databases to retrieve IDs, emails, and usernames. I ran the mix-ecto reset command, which dropped, created, and migrated the development database successfully. A harmless error about the Prometheus port being in use appeared, and I noted that you can re-register now. That's the check username query hitting the dev server, which is still running with the old database cached in memory. Try restarting the Phoenix server. The reset only took effect on disk. I deleted the SQLite files and then recreated the database by running mix-ecto, create and mix-ecto, migrate. read the account's resolver file, added constants for 5 registration attempts per IP per 15 minutes, and updated the register function to extract the remote IP from the context and invoke the rate limiter. Then I ran the mix test suite. I explained that remote IP will show trefix pod IP in production and that we need to use the x_for header instead. I edited the elixir endpoint file to add a comment and inserted plug rewrite on with x_for and x_proto before the request ID plug. I then ran the server tests with mix test.
And now reflects the implementation. So now we have login. Go. Mew mew. All the plan code. So here. So we log in basically. Here it is. And the user. Have web login.
confirmed that stage 1 is finished with registration, login, session tokens, GraphQL schema, rate limiting, WebSocket authentication, web forms, and 28 passing server tests. I outlined the server and web tasks for stage 2, noted the features that will be deferred, and asked if you'd like me to start planning the implementation.
I gotta push through this. I think I might take a break today. End early. Just take it easy. And then make a big push tomorrow. I think there's basically a straightforward path. It is worrying. It is worrying, like, just trusting this code. I have basically no idea if this stuff is correct and secure. And so it feels like I should really code review most of it. And if I don't code review it now, it's so much harder to code review later. Because it's an overwhelming amount of code. I'm not even really sure where this is implemented. I see the test file. Did I commit this already? Hmm. These are tests. I think server section is getting excluded. Did we?
I edited the gitignore to add a negation pattern, app /*//lib/ so that the server lib directory is no longer ignored. And I verified the change with git checkignore commands, confirming that the server lib files are now tracked, while the root lib directory remains ignored. I also explained that the original app /*/lib/ pattern only matched one level deep, which is why the elixir server lib path was still being excluded. edited the gitignore file, removing the generic lib rule and its related negation patterns, and simplifying the remaining entries. Then I ran a git checkignore command to confirm that the elixir and go lib directories are no longer ignored, and that the Python virtual environment handling still works. I also explained that the lib rule from the stock Python template conflicted with the project's elixir and go source directories and required fragile negation. Permission requested. Command to show stage. Permission requested. Command to show recent commits for style reference.
Bark is so loud. I think luckily I have the microphone setting set to clamp audio.
Committed, pre-commit hooks all passed, D773313.
You want your toy? You're not getting your toy. A lot of these changes. Some of our current changes probably could have Can you tell me which ones?
Permission requested. Command to show files in commit A86 FA20. Permission requested. Command to show status of files in lib directories. I examined the commit A86 FA25 and listed all files in the server and web lib directories, then cross-referenced them with the stage 1 auth plan notes. I identified 14 Phoenix scaffolding files that belong to the A86 FA25 commit and 12 additional files that belong to the later stage 1 authentication implementation.
New stage.
Permission requested. Stage Phoenix scaffolding files in the Kiwi Research project. I staged the 14 Phoenix scaffolding files.
Gosh. we need it. But huh? Yes.
Unfortunately, there is no content provided for me to clean and convert for text-to-speech. Please provide the text you would like me to process. I read the useSocket TypeScript file and replaced the token retrieval and socket initialization lines with a comment explaining that the token is passed, so the socket is authenticated for future channels such as mailbox ID in stage 3. This updates the code to clarify the authentication behavior.
How you doing, Miss Pup? So yeah. I think I need to take a look over this and just make sure stage 1 is good, that I'm okay with the auth setup and I feel comfortable and confident with it. And then move on to stage 2. In stage 2 is setting up the profiles. Okay. The profiles, one thing I'm thinking about with that is like Probably because of the load. So I have these profiles. Okay. Yeah, I'm probably gonna stop in a minute and throw the ball with her. So I have these profiles. The obvious thing to do would be to make this start showing your information. I think there's realistically going to be a decent amount of information on your profile. Like when you joined, some description, optional description, your name, your username. That's about it. Oh, and then if you're in any mutual groups, it'll show you some stuff like that. I need to think more about, does it really make sense to have sort of the public groups and private groups in the same place? I think it does, because I could imagine wanting to be in public and private groups. And I think you would understand that anything posted in public groups is not private. It's just so complicated for users to understand, like, that for private groups, they could lose the history. Like, that's so hard to explain from a user standpoint, that it doesn't just work the way they think everything else works. I think if you just give enough warning up front, basically saying stuff like that, it's fine. It's funny because I wanted to avoid doing too much. When I kind of built out this interface, I'm like, because it's just, I know it's what I do. Because I take on way too much. And the whole like encryption stuff, it's so much more than just implementing these features. Like I could reasonably implement all these features unencrypted. Pretty simply. Nothing crazy. It would work fine, work better than a lot of other apps. The encryption part makes everything so much more. But I feel like the app it's worth something without the encryption in terms of it's useful to people. But I do value stuff like iCloud or whatever that just gives people more security. Because people just don't even have any sense of how poor the security is for most. And in the long run, like, it saves me headaches too. Because I don't have to moderate private groups between you and people you know. I don't have to deal with subpoenas for them either. Alright, I think I'm going to call it I'll do some more later, probably. I don't know. I'll stream it. Wow, GraphQL slower. I mean, it's the GraphQL plus the database query. But this is taking 10 milliseconds. A lot of milliseconds. Like if I were just doing the end-to-end encrypted stuff, maybe I would probably do REST instead. But since I plan to do the public group stuff, I'll probably do most of that with GraphQL. And those groups will work pretty differently. Prototyping that out's gonna be good. I think they're almost like two separate, I mean, the way they work, but you want to make them feel the same. You benefit from having the same design system and everything, and the user's already logged in and stuff, so. I don't know if all of the... I worry that the server is going to break if I deploy this. Because maybe one of these uses the lib stuff. Yeah, like the router uses the GraphQL stuff, but it's already checked in. Oh, I guess I just need to put the front. Gosh. fix the little... It annoys me, like not knowing what the actual map is. Nice, now I don't get like multiple 100-millisecond things when you navigate away. Yep, about 30 milliseconds. Here to space to Seattle. And then Seattle to round trip. Emails. Break time. Yeah, I'm not gonna leave it on. I think I'm gonna sauna and stuff tonight, so I might do a little bit of work later, but I'm not going to. It's just the amount of work I'm gonna do relative to the amount of time I'm gonna be gone. Thanks for watching, anyone. Later.